Introduction to the Cascade Method. I am Rajesh S. Chandler, working as an assistant professor at RDML College of Engineering, Hosur. Today I am excited to share the insights into the Cascade Method, a systematic approach widely used in automated and the control system. The Cascade Method is a fundamental technique in a control engineering and industrial automation. It involves the using the series of controllers where the output of one controller act as the input to the next. The sequence, the sequential configuration enhances the system performance by breaking down the complex process into manageable control loops. The application of cascade method, the process of control, where we can use especially for the chemical and petrol industries for measuring the temperature, pressure, and the flow in the particular systems and all. The second is the automation used in the CNC machine, the manufacturing to improve the precision and efficiency. The third point is the power system, and also we can use in the marine and aerospace. This approach not only ensures the system stability but also enhance the overall performance. I look forward to discussing this further. The cascade method theme highlights the importance of stages processing for achieving the high efficiency, reliability, and the precision across the various engineering fields. It equips the students with the knowledge and the skills to design, optimize, and innovate using the cascade principle. Here we are going to see the basically the understanding of cascade. So this particular presentation provides the comprehensive overview of cascade method, where we can see the key features like application, advantages, limitations, and highlights of its the practical implementation in the software development, education, engineering, and the project management. So of course here we are going to have the two important approach for defining the cascade method. One is the linear approach. So it utilizes the step-by-step approaches where we can emphasize the sequential completion of a task or the phases, where we can get the sequential where use compared with the waterfall where the progress study flows downward through the distinct stages. The second one is the sequential stages where we can see the linear structure promotion. We can identify the advanced methods where we can see the simultaneous avoids of the execution of multiple phases and all. So of course the cascade method can be used in various applications like linear structure, even for the clear stages, non-iterative, and the documentation. In the linear structure, what exactly we are going to do is here, we are going to predict the order and ensuring that each stages the complex before moving to the next. In the second stage, where we can see the requirement of need for fulfillment of the before proceeding to the next stage. This ensures the clear path and preventing the ambiguity and all. So in the iterative method, where the reworking of various in the earlier stages that can be overcome by focusing on in the minimal revising of rework in the initial stage itself, because once the errors are occurring, so it will be propagated and then it is very difficult to get the solution for the entire systems and all. Of course here we can see the detailed documentation maintained at each stages, creating the comprehensive record and the decision progress and the deliverable. This ensures the knowledge transfer, reduces the dependency of the individual and all. We can get the overall things very easily and all. Of course, this cascade method can be used in various applications like a software development, education, engineering, and even the project management and all. Of course, now I'm mainly concentrating on the engineering and also where we can use the software development for the waterfall model for the tradition of software development for the life cycle methodology. It involves the sequence, the phases like a requirement analysis system, design implementation, testing, deployment, and the maintenance and all. So advantages of cascade method, where we can see that the clarity of each stage was defined, the objective and the output ensure that everyone understands the purpose of exactly the result of each phases. And as we can see the predictability of the sequence of tasks ensure that all the requirements are met in order to making the easier to predict and plan for the project milestone and deadline. And also we can check the that is for the controlling of each and every stages by finding the linear progression task, and this enables the better control over the project scope and the resources. And also, of course, each and every method is having its own limitations of the cascade method. So one is the inflexibility, risk of error, and the time consuming. So whatever you take the any methods and all, of course, they are having certain challenges will be there. But by fine tuning of these things, we can overcome some of the problems and all. That is the inflexibility, and even we can overcome the risk error and all. So that is of course leading to the cascade for the costly rework and all it will be carrying, and also the time consuming. So it will take the longer project time. This can be significant disadvantages in the project with the late of deadline, rapidly involving the requirement and all. Of course, this entire system we can use in the real world example, like a cascade method can be used in the software development. It is having around 6 different stages are there. One is the requirement analysis, where we can see the requirement of including the functionality, features, and the system limitations. Second one is the system design, where we can gather the requirements including the data models, the system architecture, and user interface design. After that one, next step is the implementation. Of course, whenever you are having all the details, the specification and all, then we can ensure that one adhering the coding standards and the best practices we can run. And also we can see the testing, the conducting of rigorous testing, ensure that the system works expected, including the testing, integration, listening, and the system testing. Of course, this can be do in the deployment for the various the new product, where we can use for the installation and the configuration, and we can give the training to the people. So of course, this will be very very helpful for entire system can be maintained. Then that will be helpful for enhancement of initial deployment, ensuring the ongoing stability and all. So now we can see the one of the important example for the cascade method that can be used in the manufacturing area, where the sequence of operation will be there. For example, I can say that with sequence of operations, where we can use the different cylinders and all, that is based on the number of sequences. Suppose if I am holding the component, then performing the operation and going back, means 3 different cylinders we can use for the one after the other operation and all. The first cylinder, what it will do, it will come and hold the object. Second cylinder, what it will do, so it will helpful to perform the particular operation, and it will maybe doing the drilling or maybe a shearing, whatever it may be there, that particular operation it will perform, and it will go back. And then next the cylinder A will be go back. The third cylinder, what it will be there, it will come forward, and it will push forward in the direction, and all we can take away the component. The same example we can use here for the 2 cylinder, where we are having the sequence of operation will be A plus B plus and B minus A minus, where A plus is indicating the forward direction, there is a forward stroke will be there, and similarly for A minus means retractive condition, B plus means what, that will be the forward condition of your the cylinder, and A minus B minus is the retractive condition of the cylinder. So when you are taking the sequence of operation, we can write the some of the parameters, or these things will be helpful for making the circuit diagram very easily and all. So number of pressure lines, where we can see the number of groups, how many groups are there. Here we can see the 2 groups, that's why I can write number of limit switches, because each cylinders are having a 2 limit switches. Here we are using the 2 number cylinder, then we can write it as a 2 into number of cylinders is equal to 2 into 2 into is equal to 4. The number of direction control valve, where we can have the number of cylinder is 2. The number of group changing valve, where we can have the number of groups minus 1. So like this we can represent the sequence of operations. The same thing is explained here. What is there, A plus forward stroke and A minus retractive condition, and then I have written the sequence of stages A plus B plus, and where B minus A minus, and we can write the group based on the logical condition, where the same letters are coming B plus and B minus. So the changeover, we can make that one changeover mode and all. So that can be done. Now we can see the key elements in the cascade circuit. The number of pressure lines, this equal to the number of groups and all. The number of limit switches, already told you that one. the twice the number of cylinder, 2 into 2 is equal to 4. The number of direction control valve, 2 into 1 is equal to 2. The pressure line, here we can use the 2 equal number of cylinders, that's why 2 is equal to 2. The number of group changes valve, that is what we are calling it as a cascade valve. It is the number of groups minus 1, that is equal to the 1. That is the one cascade valve will be there. The same thing is explained here. So what sort of the how many cylinders we are using, how many direction control valves are using, what sort of the limitations valves we are using for the particular systems and all, and also we can use the group valve, what we are calling it as a cascade valves and all. So then how to give the allocation of these groups also shown in this sequential operation. See here, when we want to present the circuit diagram of cascade method and all, we need to follow some standards and all. So there I have shown here double active cylinder we are using, and also each cylinder is having a 2 limit switches, 3 by 2 limit switches is shown here, and also we can show the pilot operated direction control valve, 4 by 2 valve, and pressure line is representing 1 and 2 with a different color, and the last one is the cascade valve shown at the bottom of the thing. So now we can see that one the two different sequence operation. Here we have shown A plus and B plus, B minus, A minus. So now we can show here that one the first row we have shown the number of cylinder, that is cylinder and cylinder B. The second row we are representing the limit switches 1 and 2, that is A minus, A plus, and B minus, B plus. And third one is the direction control valve, that is connected with your cylinder A with direction control valve A, and B with the cylinder with the direction control valve. And also we have shown the pressure line with a different color, and we have shown the bottom at the cascade valve, that is A plus, B plus, and B minus, A minus. Now how exactly we are going to view the connection? Now we are showing you that one A plus, B plus, and B minus, A minus. So now the connection is we have to show the group line 1 and group 2, where suppose A plus means where that is a limit switch of 2, A plus, that will be connected with a group 1, so that will be shown with the first one. A plus limit switch is connected to the group 1. Similarly for the group 2, where we are connected with the limit switch of A minus. Similarly in the right side, if you see that one, B plus, that is a group 1 is there, so that will be connected to the limit switch 2, and B minus is connected to the group 2, where that will be giving the connection. The bottom we have shown the what we can say, that is a cascade valve. So here we have shown that one how exactly that the pressure line is connected in this particular systems and all. So now we can see the sequence of operation. So now you can see the pressure line 1 is getting activated. That is what I have shown in the left side, the sequence line. So that will be connected to the direction control of A is going to get activated. That will send the signal to the cylinder A. The cylinder A is where the stroke is moving up to water, up to the limit switch of A, so where it is going to stop there. Then the signal is sent to the from limit switch A to the where VB, that is what we are calling it as a second direction controller, where I have shown the sequence to. Then the signals are coming to here, then that will be sent to the cylinder 2. Now the cylinder 2 is moving in the actuation, it is moving in the forward direction. That is what we are connecting with the limit switch B2. So that will be connected to the your cascade valve to the main valve. That is shown here. This is one step. Similarly for the in the other stage, changeover stage, the second group where we are connecting with this one. See now we can see here where we are connecting with this particularly B minus is there. No, B minus is connected to the your B minus of limit switch is connected to the your direction control valve of A, and that will be there, the signal is sending. And similarly second one what we are connecting, so when giving the signal from B minus to here, so where the B A minus is there, no, that limit switch A minus is connected to the your cascade valve. So like this one we can complete the changeover system, and we can complete the work process and all. So by using the different softwares and all, we can run the systems with very easily for this cascade systems and all. Thank you for the your cooperation and all. Thank you.